Hello all, welcome to the subject microcontroller. I am Professor Meenakshi Pancha from Electronics and Telecommunication Department, Parvatibai, Ganba, Mujay College of Engineering, Waguli, Pune. So today we have to write a assembly language program corresponding to counter. Here, first we have to design the 8051 based counter, and then we have to count the number of pulses on the timer pin and in 1 second, and also get the frequency and display the count on the LCD. First, we have to design the counter. Then we have to count the number of pulses, where the number of pins, the number of pulses present on the pin of the timer, and hence we have to get the information about the frequency and the whatever the counts we have counted, that we have to display on the LCD screen. So this is the main goal. So we have to write the ALP accordingly. So before going to writing a program, first what we have to do, we have to set the algorithm, and we have to start from the steps. First steps, we have what we have to do, we have to think like that. And let's begin. What step should be required in the main program? First, we have to, this is the first step. First step, we have to initialize the LED. These things we have already learned in the section where we are interfacing the 8051 microcontroller with the LCD display. So, here repeating once again. If any doubt, we kindly you have refer it, and it will understand easily. So first start from step number 1. First, how to initialize the LCD. After interfacing, after done with a connection, we have to check first LED. How? We have to start first, initialize the LED. Then we have to wait for some software delay. After power up, we have to wait software delay. Software delay is nothing but the delay instruction we have written in a program. So after that, the power up and display to stabilize. After initializing the LCD display, the display should be stabilized. So for that, we have to give some delay. So how we are providing that delay? By using a software. So hence it is called as a software delay. After that, initialize the LCD by giving the instruction this. By giving this instruction, what will happen? The LED will become initialized. This is second step. Initialize to command subroutine. Whatever the code written in the command subroutine, it will start initialized from there. This is the command subroutine. And after that, wait for small software delay. Then after that, we have to wait for some delay. This is the LCD. First, we have to initialize and wait for it some time to stabilize it. After, we have to initialize the LCD by giving the code 03x. So what will happen? It will enter into the command subroutine where the same codes are written. So accessing those code, executing those code, it means that some operation will be happen on this LCD screen. So what operation? Let we will see. Issue the command 0e to command subroutine for display on. We are issuing this code to our command subroutine. Here we have access this command subroutine by using this code. But using this code, what we are doing? We are making display on. Display on and set the cursor. Cursor we have to set for displaying purpose. Here display will be on and cursor will be set. Then after that, wait for small software delay. We have to wait after cursor on. We have to wait some delay for some delay. Then issue this code command 01 for clearing the display to command subroutine. So after turning on this display, there may be a something information present on the display or LED screen, there may be, normally it not happen, but if there may be a have, so we have to keep it in track like that. First we have to clear the screen. First we have to clear the screen. So we need clear screen before going to print anything on the display. Then after that, we have to wait for some small software delay time. And after that, similarly issue the command is 06 for making LCD in a increment mode, and cursor should be increment after every character is written command subroutine. So we have to pass this code for making LCD in an increment mode. So cursor should be increment after every character written in a command subroutine. So if we have to written anything after displaying it, it should be increment. It should be increment each and every character. So we can display another character. So this function will be activated by this command when we are going to issue this command to command subroutine. So let's see next. So after that, we have to wait again for small delay time. Then we have to issue this code to command subroutine to position the cursor first line and first character. So see here, what we have written, we will take here first of all. So this is the our display. This is our display, LCD display. Here first we have given a code. What code we have given? 0, 0, 3, 03, sorry, 08, sorry, 08, 038. So for initializing the command, here command subroutine get initialized. In the next step, what will happen? After waiting for some time, we are issuing 0E, this code, for display or cursor on. Then we are going to give 0 cross 0 1 command for clearing display, and next command is 06 for incrementing the cursor after every character is written on the display. Then after what will happen here? We have to send a code 08. After some time, we have to execute this 08 or issue this code to command subroutine to position the cursor at the first line and first character. To position the cursor here first line and first character we want to print. So then initialize port 2 input port key by writing 0 F0. We are going to initializing the port 2 pins of the microcontroller where we have interfaced all the data pins to port 0 pins from P0 to P07. So we are making all the pins are 0 here and other pins are high. The lower pins will become 0 and other pins will upper pins will become high. After that, initialize the output port for keyboard 0. First, at the output port, first we have to print 0. So we have to print 0. Print 0. this command we have to send to port 2. Then initialize the tmod 2026 timer 0 in a mode 2 as timer, while the timer 1 has the timer mode 2. So here at the appropriate operation of the timer, because we have to count the clock pulse where using a timer. So we have to set tmod where there are two timer T0 we have to set for mode 2 and T timer 1 we have to set for, again this is also set for mode 2. Then again we have to initialize the TL0 and TH0 register to maximum count so that when a pulse occur on the T, the pin it overflow and generates a interrupt, and initialize the TL1 and TH1 to generate the delay of this microsecond, and this delay will be execute for 4608 times to get the delay of 1 second. So what will happen here? There are two timer here. Itself a timer. There are two lower bit and upper bit are there. Those are like a registers. Those are the register and TL0 and TH0. We have to set the maximum count when the pulse occur on the these T pins. Whenever the T pin, the count will be occur, we have to set it for maximum time, and its overflow the generates interrupt. Then it will become overflow after counting pulse. These are the 8 bit. This is 8-bit register and this is 8-bit register. We have to count using this register whatever the clock pulse occur at the pin T. If the overflow will be exceed, all the bits of this register become 1111 high. Then after it's again counting the pulse is nothing but the overflow will occur. So if the overflow occur, we have to generate an interrupt and initialize the TL and TH to generate a delay for 217 microsecond. So after generating interrupt, what will happen? Both the register TL1 and TH1 will become initialized and generates after initializing, which have to generate the delay for 217 microsecond. And how this delay will be occur? This delay will be occur executed 4608 times to get the delay of 1 second. Whatever the delay we have written the code delay purpose, it should be execute how many times? 4608 times. Then it will generate a 1 second delay. So after that, initialize the LCD to first line and first character to calculate the 1000 digit and display it. Then again calculate the 100 digit and display. First initialize, after initializing, we have to display the character one by one, whatever we have calculated in the command in the program, it should be displayed. First, it will calculate the 1000 digit and display. Then after that, first it calculate, then again it will calculate 100 digit and display. Again 10 digit displayed, calculate the unit digit and display. And also display the character H and Z for the unit for frequency hertz. So this calculate this display for displaying the frequency and repeat the steps, the same steps onwards continuously displaying the fresh count. From here it should be repeat. The repeat again we have to repeat the steps from this X is nothing but here. Again we have to repeat from this same function to continuously display the refreshed count. So this is the some steps of the main program. So we have to execute these steps. Now there are some few steps we have to follow for the command subroutine and data subroutine and also delay subroutine. So let's see what are those steps. I will clearing these. here. Let's go for next slide. See here some steps. These steps are for command subroutine and these steps for data subroutine and also ready subroutine. So we have to follow how to perform a task in a subroutine and how to using these steps we have to write as a assembly language program accordingly. So first step is give the instruction to the port connection to data bus to the LCD. So here first we have to provide the instruction to the port which connected to the data bus of the LCD. So what instruction we have to provide? First we have to make RS is equal to 0 and then to indicate the instruction, and after that R by W bar, read by write bar is equal to 0 to indicate write. Again E is equal to high, enable pin. E is nothing but enable pin and which will high and wait for 120 microsecond, and again enable should be become reset and after return. So these steps is nothing but to give a high to low pulse to on E pin so as to latch the command. For latching purpose, the command subroutine, these steps should be required. First, we have to provide a low signal on RS and read and write bar pin. After that, we have to enable, provide high signal on enable and wait for some time and make it reset. So what happen? It will provide high to low pulse on E pin. So the latch the command. So after that, what function should be performed in a data subroutine? In a data subroutine, first check if LCD is ready by calling ready subroutine. First, we have to make ready subroutine for the LCD. After, give the data to the port connected to the data bus of the LCD. Then we have to make RS equal to high and read by write bar pin low. Then the same operation which we have done with the enable pin on the command subroutine we have to perform here same. First we have to make high signal, we have to provide high signal for the enable, wait for 120 seconds and after reset it, which means it will provide high to low pulse on the enable pin. So here, there, what will happen there? Latch the data, but in this data subroutine, it will latch the, in the command subroutine, it will latch the commands, and here in the data subroutine, it will latch the data. So let's move to ready subroutine. In the ready subroutine, make busy pin. First, make busy pin high is nothing but whatever the data pins of this LCD connected to the port, first we have to provide high to program corresponding port as a input port. So first we have to make all the ports pins of port to high to initialize the port pin as input port. Then make RS is equal to 0, indicate the instructions. Then the same here, listen here, the enable operation will be opposite here. First we have to E should be make 0 and after we have to make 1. And read by write bar become high to indicate read function and check if busy pin is equal to 0. If it is 1, indicate the LCD is busy. Hence again make E low to high and check the busy pin. Repeat the same operation till the busy pin will become 0. There is a busy pin. We have to monitor that pin repeatedly. How we are going to monitoring? If those pin is the busy pin, there is a low signal on that pin is nothing but we have to wait for some time and perform operation low to high on the enable, and we have to monitor again if the busy pin equal to low until the busy pin will become no. Then we have to return from this subroutine and ISR of the timer 0. Here interrupt will be generating for the timer 0. Increment the count until it is 999. After every pulse on T0 pin, once the count reaches 999, stop the increment it. This is the here writing the interrupt program. Well, when the timer, whatever the T0 register will reaches the these digit higher value 999, then the timer should be stopped. Then for timer 1, decrement the count until 0 every 217 microsecond. When after delay it executes, so how we can provide this delay? By executing the command 4608 times and it completes the 1 second. Once the entire delay of 1 second is over, disable the interrupt so as to stop the counting the pulse on T0 pins. Okay, this is the steps we have to follow while writing the program. Let's see how the register value of for generating interrupt we have selected. It will comes from the set or reset bits of these registers. Here first register is a interrupt enable register. The first register is interrupt enable register to enable the global timer 1 and timer 0 interrupts. So for generating the interrupt purpose, how timer 1 and timer 0. So here these are required bits should become high. D1, this D1 should be high and ET1, this pin should be high. So, and ES should be low and EA, enable access, this pin should be high. So, these are the bits we have explained in a timer part in the lecture. So, according to this, the 8A data we get. So, for setting the timer 1, timer 0 interrupt. So here that data we are going to pass for generating the interrupt in a program. So how we can select the mode of the timer? Here first timer 0 as count in mode 2 and timer 1 is count in a mode 2. Both should be operate in a mode 2. So according to that we have to set or reset the timer here. See, this is the timer 0 and timer 1 set bit. Here M0, M1 is nothing but this become mode 2 and this is also mode 2 and this C by T bar should be become high for this and high for low for this. So this will generate the data to 6. So this 20x26 data we are passing in a program to executing this code is nothing but both the timer will be entered in a mode 2. The timer 0 will be count number of pulses on T0 pin. Hence, it is initialized to 0 FF. So that whenever it overflow will cause an interrupt and hence increment the count. Since it is in mode 2, as the count FF will be loaded into it. So when TL equal to FF and TH equal to FF, it will reach maximum value. Then what will happen? Timer 1 will be used to generate a delay for 1 second. Hence, it will be initialized to 55 so that it generates a delay of 217 microsecond. And for we have to execute the instruction for 4608 times. It will result provided by 1 second. So we have to load TL equal to 55 and TH equal to 55 here. For initialize, we have to initialize this by value TL and TH by the value of 55. So let's write the program.